session, you have uh, understanding of each of this entire jargons, which is around EMR, EMR serverless, what exactly, how you can do data analytics and all. As well as I've written an entire four series, or I would say four blogs in a series about covering more advanced perspective also of EMR serverless. At the end of the session, I will share that blog links also for the future references. With that, let me start ahead with the today's session. So what I'm going to talk about, what exactly are we going to cover in today's session? So we'll talk about what exactly is EMR serverless. So I'll try to cover up the basic introduction, hello world to EMR, and then moving towards EMR serverless. I'll talk about how exactly EMR works, the benefits, why exactly Amazon or AWS is offering EMR, common pattern, how I've seen different patterns moving around it, some demo pricing, and if you have any other questions, we'll try to have some time for the same. So I think from a speaker perspective, Gavaskar has already done a fantastic job to cover about it. But let me quickly give you a rundown in a minute. So I work as a data analytics and cloud practice lead for AWS business at Quantify. So that exactly it shows in and out. I work on AWS, and my responsibility is to run different services, work with the customers, and help them to solve their industry problem, what they are going through it. From a recognition standpoint, I'm an AWS hero, AWS ambassador, MVP by Cloud for You for last 2022 and 2023, as well as an I'm AWS user group Mumbai lead. Speaker standpoint, I've done different sessions. I've done multiple sessions at this platform itself, multi-cloud for you, as well as given a session at AWS reInvent last year in 2022, as well as given in other international platform itself, like you talk about in AWS India Summit, AWS India Community Day, and other colleges and institutes. You can follow me at any of this LinkedIn, GitHub, and Twitter. I'll share the link of all of this social media platforms. If you have any questions which you are not comfortable to talk about, maybe in the chat or in this session, or we run out of the time, I'm always happy and available on LinkedIn also as a messenger. So just DM me, send me a question, and I'll be there to help you out with that. So with that, we are finally to our topic. What is exactly Amazon EMR serverless, right? So first we talk about, before I go to Amazon EMR serverless, let me quickly run through what exactly is Amazon EMR. Most of you on the call, I'm sure whether you would have heard about big data, right? At least if you are working around it or not, but you would have heard about something called as big data. If you are an data analytics guy, you're working on data, then you would have heard something called as Cloudera, Hortonworks, and those kinds of other platform, enterprise data platform, which used to provide or provides the compute capability to run big data, solve the larger volume, variety, variance of data. So that's exactly what cloud has done is, with seeing that gaining popularity of those kinds of an enterprise platform, each public cloud you talk about, whether you talk about Azure, whether you talk about Amazon, whether you talk about Google Cloud, started offering their own managed big data platform, right? The whole advantage of all of this cloud, the bottom lines remains the same. How we can simplify our journey of our customer so they can focus more on their business application rather than worrying about the infrastructure. That is somewhere where that's the bottom or the moral of the story is of all the clouds. Whichever service you take, whether it's machine learning, AI, DevOps, or data analytics, end of the day, they always want to simplify the journey of their customer. And this session is more focused about AWS, Amazon Web Service. So Amazon also does the same thing. And they launched a service called as EMR. Previously, when they launched it, they also called as Amazon Elastic Map Reduce. So don't get confused. Elastic Map Reduce or EMR is the one and the same service. They rebrand this as Amazon EMR. Now, the best part about this EMR itself was also, I have personally worked on Cloudera, Hortonworks, and as well as on Amazon EMR. There are pros and cons of each and everything, but at least the best part about EMR, which I liked it, is you don't have to really get into the complexity and nitty-gritty of setting up all the configurations and all the thing, right? So if I put myself as more like a Hadoop admin, right? That was a prominent role 3 years, 4 years back. We used to see a lot, right? That role some or other way has demolished, have disappeared because of this cloud thing, right? Again, many people will not agree to that fact, and I am completely with you guys. It depends on what organization really wants to do. In EMR also, when you have very larger cluster enterprise scale running 24/7, you need Hadoop admin. But again, that rule, some or way of Hadoop admin has been become more versatile on the cloud. Now it has merged with Hadoop admin plus DevOps kind of a person, which previously was Hadoop admin. So now this Amazon EMR allow you to run Spark, Hive, Presto, HBase, Flink, Pig, those kinds of different scripts, which you can do in Hortonworks also. You can do it now here also. Within simplified on Amazon EMR, you can do all of these things simplified it. Even you can have rangers and those kinds of governance policies, HBase, Ranger, HDFS, those kinds of good stuff you can have in Amazon EMR, which you used to do in Hortonworks. You have to pay a lot of cost in Hortonworks. You have to do lots of management and operational on those enterprise data platform. With some or other way, here it gets simplified it. So that was a big paradigm shift where people started moving with the adoption of the cloud. They started shifting more towards Amazon EMR, where Amazon EMR out of the shell provides latest versions for all those kinds of open source platform and applications, provide best performance and cost, right? That's the whole USP of the cloud, is that they can use competitive cloud, no investment, upfront investment on hardware and all. So those all things gives you the lowest cost. The one of the best thing why I used to like Amazon EMR was SDFS, which was a prominent disk storage, right, for use for file storage in Hadoop. In case of Amazon EMR, they clubbed it with something called as Amazon S3. Now, Amazon S3, if you don't know about Amazon, then Amazon S3 is like a backbone of any services. It's a highly scalable, highly durable, the longest running service of Amazon. According to my experience, it has only crashed once in my entire tenure of last 9 to 10 years, which I'm working on Amazon. There was only one time which I've seen Amazon S3 was not available. It's a very highly durable service, I would say, and highly scalable. You can just think of like it's an infinite scalable service. Now, Amazon EMR provides the compute with the storage durability and expansion elasticity of Amazon EMR. That's the beauty of it, right? That you don't run out of the disk, optimize the disk, clean it, which was overhead a lot in those enterprise data platforms, which get erased by having this with help of Amazon S3 and elastic and scalability. Now, we all know about the USP of the cloud: cost, elasticity, managed services. These are the 4-5 things which they provide out of the box, which makes us as a customer simplify our life, which is what Amazon EMR came out of the box, that you do continue processing your large variety of data, continue using the applications, open source applications, without really worrying about the infrastructure cost as well as the scalability part of it. So that's exactly what Amazon EMR used to offer. Moving towards the next slide. Now, what happened is, this is what even I used to face. Why exactly I want to even pay for Amazon EMR, right? Still, end of the day, Amazon EMR also used to have the same concept. There was a master node, there was a core node, there was a task node, right? All of these jargons are very similar when you even use data platform. So for the folks who are not aware about it, as simple as we go back, there is a master and there is a slave. Master is like a brain and slave is like a workers. That's a simple concept. When you talk about cluster, that's a simple thing. Amazon EMR also follows the same thing. There is a master core node, there is a master node, there is a core node, there are task node. Now what we have to do again is, in case of EMR also, you have to form this topology again. The cloud did simplify the setting up the infrastructure and all, but still you have to set up the cluster and all. Now, one side, there was a Lambda and there was good other stuff which AWS provides as a serverless. Lambda, or even if someone has good understanding of AWS, they provide something called as a serverless ETL pipeline, which is under the AWS Glue, right? Where you can run the Spark jobs. So other sides, customer like me, were always referring to the Amazon. If you can provide Glue as a serverless, why can't you provide Amazon EMR? This is honestly one of the feature which even I was requesting AWS a lot, that why exactly you cannot provide Amazon EMR as a serverless. And that's exactly the interesting thing that happened, that at reInvent 2021, we saw that AWS announced EMR serverless. Now that was like a cherry on cake, the next level of Amazon EMR. The Amazon EMR was already providing the scale of processing the data, big data, they took that to the next level by providing the serverless. Now you even have to don't worry about the configuration of the servers, like what number of servers, the cost of overrunning. Like I personally also have seen that there are many aspects when you search about EMR, the people always used to complain about that I got charged more because I left over my cluster or my cluster got hacked or other kinds of stuff. Since EMR serverless was managed, you only pay for the cost of that server till the time your application is running. That is the only the cost what you're paying. And the worker nodes are dynamically scalable, which you will see in the demonstration in the demo, as well as those upcoming concepts in detail, what exactly that stands. But AWS simplified further by providing simple to use. Since it is serverless, just think of you don't have to manage any servers. AWS will take care of heavy lifting. It's very fast. Now, fast in the sense is you don't have to set up the application. Just keep focusing writing your business application, whether it's on Hive, whether it's on Spark, or whether it's any other thing. Focus on your application. There are already workers which are bootstrap. What I mean is there are already applications which are there in those servers. You don't have to worry about it. Cost effective, as I mentioned, since it is serverless, you're only going to charge till the time your application is running. You don't have to pay for that additional cost. And it's very comprehensive. The last point is it's very comprehensive because the same thing like using EMR studios you talk about, or debugging, troubleshooting, those all kinds of things still remains as is, which was provided in Amazon EMR, we refer to it, or that was provided in some other kind of a big data platform. So even your data science team can use the same way they were using the enterprise data platform or Amazon EMR. Even your data engineers can use the same thing, right? Your platform team can troubleshoot the cluster, any failures of the jobs or any logs with a Spark UI and those kinds of stuff. So all the features remains the same. They simplify the infrastructure, they reduce the cost and provide the fast scale. So that's exactly what the power of the Amazon EMR serverless was. Now let's understand what could be the possible use cases of using Amazon EMR serverless. So as I talk about, interestingly, building a data pipeline which is very scalable. If you have terabytes and petabytes of data, you can easily scale those things because you don't have to worry about the infrastructure now. Even in Amazon EMR, or you talk about the enterprise data platform, you have to scale your servers. You have to add nodes, right? Machines to it. If you're running on-prem, then you have to add the physical servers to it. If you're running on the cloud, then you have to use auto scaling and expand your workers. In case of EMR, you don't have to worry about that. So that simplifies further that as an end user, as a data engineer, I am very much focused to write my business applications and processing my data rather than worrying about the infrastructure part of it. Two, as I mentioned even in the previous slides, your data science team can use the EMR studios, the Jupyter books and those kinds of stuff and process the data, write the books and all, notebooks like Python code. They can still do the same in this particular setup also without even worrying about the infrastructure now. Real-time data streams that remains the same, and query any data set with, since it uses Spark and Hive. Hive is, I mean, almost similar to how you can do like a SQL kind of querying. So you can connect Hive, flush the data to S3 as a storage, and you can have Athena on top of it, which is via glue catalog, and you can do all kinds of query of that data set and everything. So not only Amazon EMR reduce the overhead from a platform standpoint, but the another side, if I see as a data guy, they simplified it very well with integrating the native services of AWS. So now think of like if you want to really do a big data, it's very challenging that you have to learn all of these new things, the cloud, the big data space, hire people. Now with help of managed service, which is provided in form of EMR serverless, you don't have to worry about it. Whatever the application you were running before on premise, you can easily accelerate it on AWS and as well as integrate with other best services, like the other services which are part of out of these sessions. Those services also from a security, governance and other good standpoint, you can integrate with EMR serverless. So not only they provide you the good rich sets of features as well as more use cases what you can do. So that's about was the Amazon EMR serverless. Let's exactly understand on a high level how it used to work, how it helps to solve the problem. Let's say previously also I mean, if you are coming from a traditional thing, you would have heard something called as Uzi workflows, or you had some other Airflows, which is a new orchestration, very renowned in the market. If you come from a, let's say, cloud background, then AWS, then you would use something like a step function or any sorts of data pipeline, right? Or let's say simple, very simple Python code or SDK. Whatever the medium is, you can see with help of any medium. It could be even a Jenkins, right? Or any medium, even from your local machine. If you have a CLI install, you can easily spin up or start a new application by defining what kind of application it is. Is it a Spark? Is it a Hive? Which version, what you want, and other configuration. And behind the scene, you will see that the entire EMR serverless, since it is managed, it will be deployed in their application environment, like the workers will be deployed, which can be easily integrated with other of these good services like RDS for Hive Meta Store, which is the case, right? Like in serverless also, you can have this Hive Meta Store. You can have CloudWatch for logging monitoring, KMS for encryption, Glue data catalog, as well as S3. So you can have all those kinds of security, governance services along with cataloging with this entire managed setup also. So that's the thing. You don't have to worry or compromise the way you used to work. AWS intakes and take care of everything around it. You just have to start, play around, and focus on writing the code. So we'll see the same setup when we will be doing the demonstration in some time, where I will use CLI to start the application, CLI as well as CloudFormation to start the application, run a Spark job with help of S3. So this is how as simple, which used to be very complicated in enterprise data platform, get abstract and you can focus writing only on your business application. Now let's understand each of the aspect very quickly. How exactly it is simple to use or other kinds of feature which I've been talking about a lot, right? So first of all, it is simpler to use. The reason is you can pick up any open source framework. So when you will be going to the AWS console, you will see with simple application form, I can easily switch between, you talk about from Hive to Spark with just a simple click. The best part is even though AWS provides this as a managed service, both Spark and Hive are open source framework. So you really don't have to worry about that, okay, no, I will be in a vendor lock, or what happens if I want to move away from Amazon to again back to my on-premise. You can do still all those kinds of stuff, right? So that is more simpler, that you don't have to worry about vendor locking or you lose the capability of cloud agnostic. You can still do that without worrying a lot. And other, if you see from the platform perspective, right? You don't, since it is a serverless, you don't have to worry about scaling the infrastructure. You don't have to worry about patching, maintenance of the servers, right? Which you always have to do when you're doing on-prem. If you're really doing an on-prem, you have to patch those Linux servers, clean the disk from terms of logs getting accumulated, and those kinds of stuff still remains the same. Where here it gets simplified to use, you don't have to worry all those things. So not only from a platform DevOps kind of, their headache is simplified, even from data engineering perspective, it is simple to use. Need not to guess cluster size, very important from cost as well as the entire productionalizing the standpoint, right? Whenever we do any data pipeline, the more important thing is you have to do lots and lots of benchmarking in a traditional way. So that way you can understand, if I am processing my data for, let's say, 5 gigabytes of data, then I need, let's say, 3 servers. If I want to do like 15 terabytes, then I will need, let's say, 100 servers. Those kinds of arithmetic calculation you have to do. So rather than writing your code, you are more worried about benchmarking and identifying what will be my right cluster size. Here in this case, you don't have to worry about it. As I mentioned, since it is highly scalable, you really don't have to worry about guessing your cluster size or doing that over optimization and benchmarking and spending your energy towards it. So you can easily scale up, scale down, since it is serverless. And even from the cost standpoint, right? Not only just that, cost standpoint also, you're only going to charge for the number of workers that are running. So let's say even in the data pipeline, you have 5 jobs. Each job needs a different numbers of servers. You're not only going to be charged for that pipeline, but the charging is so optimized that the number of workers which is required for each job, you will be charged for that. What I mean is, let's say you have 5 servers for one job, 10 for second, 5 for third. So the pricing will be for 5, 10, and 5. It's not going to be much together for 15 servers, right? So that makes it more simpler for you guys, that this is like if you have a larger pipeline running for 50, 30 number of nodes, the costing based on the time what you use as well as it is very minimized it. So that's the other advantage what you can see from the scaling from a time as well as cost standpoint. All the benefits of Amazon EMR without managing the cluster. I think I've covered up a lot in the previous slide. Not only you get all the applications like Hive, Spark you can run, not only you can interact with EMR Studio for the data science team and data engineers, as well as you can connect with step function, with Airflow, CLI, cloud formation, those all things from data engineering, data science or platform, from all the three personas, you can easily play around with serverless what you were doing in Amazon EMR. That's one. Second, if you have already developed any applications which is running on Amazon EMR, you don't have to worry about moving towards EMR serverless. So if you are already a customer or a kind of a client who's already using Amazon EMR, you don't have to worry about it. You can easily take that application, the jar files or the Scala code which you have developed, and put it into Amazon EMR serverless. So the importing to EMR serverless is also very easy. So let's look into the cost thing, which I was covered up like a while back in the slide, right? Let's say we have three stages. So from a cost standpoint, let's say we have three stages, right? Three ETL jobs, job one, job two, job three. As I given in the example, previous example also, the job one, let's say need 10 workers for the first 10 minutes. The job two or the stage two needs 40 workers, and the third needs the 5 workers. Now, generally, anyone would expect that, okay, it's going to maybe charge for the 40 workers because that's the highest one. That's what you have to spin up at the start of the pipeline. In a traditional way, I would have done that thing, right? Calculate the maximum what I need, and automatically the lowest one will get reconfigured, and the maximum is what I need to set up and pay the cost. Let's say for the entire 25 minutes, I have to pay the cost for the 40 workers, like 10 for this entire first job, 10 for this, and 5. So totally 25 minutes, I have to pay the cost for the 40 workers. Let me tell you, Amazon EMR serverless doesn't work like that. So you're going to charge for, let's say, 10 minutes, the 40 workers, 10 minutes for 10 workers, 40 minutes for 10 workers, and 5 for next 5 minutes. So for 25 minutes, right, you will be not charged like for 55 workers, but you will charge for the duration of it. So it's based on the time slice duration what you have for each of the job, you have to pay the cost for it. So that makes it more easier if you do that cumulative of 40 server for 25 minutes versus this cost. You will see equivalently there is a cost optimization of somewhere close to around 45%, which is huge, which is very huge, that you can get that 45% of cost reduction even if you're using, let's say, some transient cluster in EMR, which is only be available to the through the duration of the ETL pipeline. If you compare the benchmarking of that cost versus Amazon EMR serverless, still you will see a reduction of the cost in 35 to 40% of it, which is very optimized. Transient cluster is called always the optimized version. Then also you can see the cost benefit. So that's the advantage of using Amazon EMR serverless. Next, resilience to availability zone failure. Now, again, this works fine even in case of Amazon EMR because you can auto scale, you can have those kinds of setup, right? One of the drawback, if I talk about 2 or 3 years back, the master node was just a single zone. So I have personally burned my hands because of that stuff. But even they have moved away from EMR also. Now they have multi-zone, like you can have the clone across multi-AZ kind of thing. And in case of serverless, now that's a beauty of serverless, right? You don't have to worry about at least the availability zones and all, because since it is serverless and AWS is managing the infrastructure, they will take care of it. We don't have to worry because it's a regional service from day one, which is the beauty of all the serverless applications. That means that, let's say, if you are processing or setting up your Amazon EMR in North Virginia region, which has like almost 6 to 7 availability zones, we don't have to worry about setting up that. Amazon EMR team will take care. The AWS team will handle if there is any zone failure which takes place. They will take care of it. They will take care of that particular stuff. So we don't have to worry about that thing. Moving towards next. Enabled secured and shared application. Enable secure and shared application. Now, one of the thing what we always do in case of EMR, also we use IAM roles for passing around it. In case of if I move towards, let's say, Hortonworks or those kinds of other enterprise platform, since they were running on-prem, right? Many people have also seen they are running on the cloud. So if you're running on the cloud, then you're fine. You can use that as a part of when you're configuring the site .xml and those kinds of other config properties. You can either provide an IAM role and access key secret key. They have also upgraded themselves. But if you're running on-prem and if you want to access AWS cloud, you have to provide access key secret key. That's the only way what you can authenticate. So there, in that case, there's a downfall if access key secret key get hacked or those kinds of stuff, right? But if you're on the cloud, then that becomes very simple that you don't have to worry about all those kinds of things. AWS takes care of all those kinds of IAM roles, right? You just have to pass the IAM roles, and that IAM roles can be very, very refined that, okay, I need this particular S3 bucket or I need this CloudWatch logs. So not only it provides you that scale or sets of features, but it also come up with a very list privilege access. So from a security and governance, who are the folks here, participants who comes from a security background, don't worry, even though it is a serverless, you still have many mechanisms to tighten the screws of it. From a governance standpoint, from security standpoints, you can define it very list privilege and make sure that even though if it is serverless, you have very refined controlled on each of the tasks and jobs, the kind of resources they can access to it. So that is very good thing when it comes to shared service applications. The 7 is enable interactive application. I think even in the features I mentioned about using the EMR studios, which itself you can do, you can interact with EMR, right? You can use the Spark UI, the Tej UI, those kinds of UIs you can use for troubleshooting, which makes it very easy to interact, troubleshoot the applications, and as well as measures their performance, right? In general, I've seen like when we started working on the serverless, right? In 2015, troubleshooting was very difficult in general sense when we talk about serverless, right? Irrespective of the service. But if I see like 7 years, 8 years down the line now, serverless have way moved ahead in terms of giving that visibility of what's happening in that black box. Like previously, everything when we talk about serverless, people used to get scared that this is very black box to us. We have no idea, no visibility. There is no way I can track the performance and those kinds of stuff, which now becomes very easy in this particular kind of scenarios where you don't have to really worry about that. No, it is black box. I'm not getting logs. I don't know how my lineage is working, data lineage, or what is my time. I don't even know how I can optimize it. Those all things are all possible in interactive application. You can get access of all those kinds of application UIs as well as EMR Studio, which gives you more visibility. On top of it, as I mentioned, one of the beauty of EMR serverless is, even though it is a serverless, it provides pre-installed a pool of workers. What that means is there is already a bunch of worker nodes available which has application bootstrapped in it. So what if you want to run a Hive, automatically you don't have to go configure in that serverless. They will come out of the box configured. You just have to define what kind of application you need to run and other properties of that application. If you take care of all those kinds of things, AWS EMR serverless, you can easily use it without really worrying about it. Easy to switch deployment model. So as I talk about when it comes to EMR, traditional EMR, it can run on ECS, EKS, and Outpost. Now even with the serverless. With serverless, as I mentioned, if you already have some application, Spark application, which you are running on EMR, you don't have to worry about. You can easily switch the runtime without even changing your deployment model. So even if we saw in the previous slides, right, whether you have CloudFormation, CLI, Airflow, step function, whatever and however you were leveraging Amazon EMR, I mean those orchestration service with Amazon EMR, You can leverage the same architecture for this one. You might have to make some small changes in the way the APIs or the SDKs are called. So it's not like Apple to Apple, like you easily change it and it will work. You have to make some small changes in the SDKs, but major lifting of importing the application, the business logic is still the same. You don't have to worry about those kinds of things, which is a very heavy headache when you're moving from one deployment model or one platform to another. In this case, it is very much simplified around it. Now let's understand quickly. This were the all advantages, or I would say the USPs of using the Amazon EMR serverless. Let's quickly jump to around what exactly are the core concepts, right? Because these are the languages which I will be talking about when I'll be doing the demo. So the first is called as an application. Now, very simple. Application is nothing but the different framework what we have, right? Like either I will use Hive or Spark. That is called as an application. Like that application is like an open source framework and the versions, like which version, what kind of application is this? Like, is it a Hive application? Is it a Spark application? What version of Hive, what version of Spark, and what other configurations I'm giving to maintain that logical environment separations. So it is not necessary that even let's say if I'm using Spark, that I need to use the Spark the same for one application versus other. No, it could be different, right? Based on the data set, based on how the code has been written. So always everyone wants to use the latest version, but it is not necessary. Sometimes the codes are being written in a very outdated framework, but still you want to use EMR serverless. And again, for each of the different pipelines, you want that flexibility. Like then you can create different applications, and each application you can define that that particular job or the code, what version of Hive, what version of Spark you can use. So not only you can use that as a logical separation or isolation between your teams, types of applications or types of environment. Those all kinds of things what you can do in case of application. So first one is application. Second one is jobs, workers, and pre-initialized workers. Now let's understand between these three, what are these three all about. So first one is a job. Now job could be the same thing, right? How we have a task. In case of ETL, we gave a task, right? The same is a job. Now job is like an actual request that, okay, I created the application, but this is my job. Job could be as simple as, here is my script, here is my data, please go and process. So job in a simple layman language can be called as a request to execute the type of application. And you have to provide other details like the execution role and all too, so it can interact with different AWS service. Now workers are the actual machines, even though it is managed by AWS as a serverless, they have branded it as a serverless, but somewhere the compute needs to run, whether it's an AWS data center or in our account, somewhere it needs to run. So there the workers are nothing but the compute node where this entire job will be executed. Again, Hive jobs or Spark jobs, what kind of data set, what kind of script, it is Spark script, SQL script, those all kinds of things which get executed on the worker. And pre-initialized workers are where on the fly, whenever the EMR serverless comes out of it, out of the box, there are certain nodes which by default gets into it. What that means is now, when it comes to workers and pre-initialized workers, there's a very thin line. Many a times you don't know that this EMR, how many servers or what kind of load that will come up. In that case, you can go with the worker. Many a times you know that at any given time, I will at least need 5 workers out of the box. There might be 5 plus 5 or 5 plus 10, but at least I need 5 workers. In that case, you can have the pre-initialized node that becomes like a default start. Whenever the application start, it will always start for the 5 and you will pay the cost of that 5 plus n whatever you have. In case of worker, you always have to not worry about the cost from the start. As and when requests come, it will come up. So to avoid some sort of a start time delay where people use pre-initialize versus the actual worker. Common usage of Amazon EMR serverless. I think now it becomes very simple for you to understand how exactly EMR serverless would be used after we covered so many features and the services about it. So data pipelines, right? Previously, if I talk about these data pipelines, you start, determines a cluster, create cluster, submit job, and terminate the cluster. This is what the sequence used to do. But now with Amazon EMR Serverless, as I mentioned, you don't have to worry about managing the infrastructure because that AWS will take care. You start the application, create an application and submit the job. So that's only the two things what we have to do. We really don't have to worry about optimizing the cluster infrastructure and all. Okay, obviously you might have to optimize your job. However, you have written the Spark and the Hive job, but you don't have to worry about optimizing the infrastructure. So that becomes very simplified when it comes to a data pipeline. Now let's take a very simple example with some whiteboarding how exactly this will work behind the scene. So for a very simple example, on the left side, you can see there are four tasks, four jobs: step A, step B, step C, and step D. Okay. And there is an application A which is running here. At the default, when you start the application, there will be 0 worker because this is not a pre-initialize. These are the normal worker nodes. So this becomes the current state, right? Whenever you start the application. Whenever the step A runs, step A needs 3 workers. So the current count of the worker will be only 3. And you're only paying the cost of those 3 workers. When you're running step B and step C, you need 8 and 10, total 18 worker nodes. So you're not only paying the cost of the 18. The first step, 3 clusters are already decommissioned or terminated. So let's assume they were used for 5 minutes. So you're paying the cost of 3 nodes for 5 minutes, 18 nodes, let's say for 10 minutes. And then you're paying the 10 worker nodes again for step D. So totally you paid 5 nodes for 5 minutes, 18 for 10 and 10 for 10. So that becomes like 25, 25 and 5, 30. For 30 nodes cluster, you have not paid around the cost for 30 nodes. You have paid the cost for whatever the time frame you have used. If you see the previous examples, what I gave. So that's how it makes more cost efficient, which formula somewhere I gave like 35 to 40%, even the compared to the transient cluster. So that is how the data pipeline pattern works behind the scene. Now, when it comes to decommission, and again, once the entire pipeline is done, it's stopped. This will be the idle state where we started around it. So this is how the data pipeline works. Like you start the data pipeline, which means start the application. At each step which runs, the number of workers will be spin up, spin down, decommission, and at the end of the pipeline, you will be back to worker count as 0. The second one is the shared cluster. Now there might be many of cases where your team will be using around with shared, right? So in case of previously, when you're using an on-prem, you would be using Yarn, a resource manager, right? And simple for the folks who are not aware about Yarn, it's yet another resource manager, which is used to manage the resources across the cluster or queues. So based on the resource permission it used to have, based on the available resource, it used to put your task under execution. So let's say there are 4 different ways you can put it, like airflow, step function, data engineer 1 and 2. That's one way you can do. But it becomes very complicated because someone has to really wait. Let's say if the pipeline B puts like around 400 tasks of ETL, then you really have, pipeline A, job B have to wait because it's a defined cluster size, right? It's not going to scale beyond a certain threshold. You have to still wait about it. So there is a starvation at any point if there is an application or a person has fired too many jobs before you. But in case of Amazon EMR, at least on EC2 instance, what they have done is they have tried to solve this with auto scaling. That still there is a starvation. People have to wait in the line, but you can, if you know there are certain things which are very business sensitive, time sensitive, and required for your business, you can leverage EC2 scaling. Like you can scale your EMR workers and process it. But with EMR serverless, what they have done is you don't have to wait about it. As I mentioned, it's a serverless. So even if you have anything, they will put this into Spark. They will easily spin up all the clusters behind the scene for the worker nodes. So there will be a small time which will be in the queue, but that will be like almost you can think of a couple of minutes versus which was hours. or at least 30-40 minutes in the previous cases, in the previous two pattern. So that's how, not only from a cost, but even from the scalability standpoint, how this pattern can solve the shared application thing. The third is the interactive applications. So let's say this is where exactly we will see the pre-initialize worker thing. Like pre-initialize, by default, whenever you have, let's say someone is using EMR Studio, someone is using some sort of a streaming dataset queries, by default, Amazon EMR application can come with an initial capacity. So when you are defining the Amazon application, you can say initial capacity equal to 10 or whatever is required. And you will see that the state and this application will spin up as a warm pool of application. Warm pool means that whenever the things comes up, it will be ready to serve the request. Now, as and when the worker starts, an application starts, even though you have a warm pool, the worker count will be 0. They will be ready for the task. So, but whenever you start the application, that is the moment when your worker will be start and the cost will be start, even though you have the request or not. That is one of the things you have to watch out. Even in case of pre-initialize, the billing will start as soon as you start the application without even the request, which anyways you have to start the application so you can serve the or accept the request. You have to start the application. Now, let's say job A needs 3 worker nodes. So out of 10, they will consume 3 workers. Job B needs 7. So it is going to consume all the 7, right? So pre-initialized capacity is used for first. And then it will become as a third one, where it's not going to wait for it. The job 3, which needs more 5, because 10 are already used by the first 2 jobs, it's not going to put the job C in the queue. It will start executing it with a normal worker, which is going to spin up on the fly and serve the request. So there will be some downtime, or I would say some waiting period will be required, but that waiting period will be very minimum compared to the waiting in the queue forever for the first 10 jobs to finish. So that's how this auto scaling or things which used to work in Amazon EMR works in this particular fashion. And once all the jobs have been finished, it will by default back to the 10 jobs once around it. And this is how the entire, when the application stops, all of this cost, the application will be in a standby mode with the 10 pre-warm server. So that's exactly the entire logic works when it comes to data pipeline, when it comes to the entire shared cluster or interactive. This is all is very important for you when it comes to designing the architecture. Now you would say, since it is serverless, manage, what I have to do, why I have to do this all, right? But it becomes very important if you are playing a role of an architect, or if you are really the play system designer. These are the factors what you have to consider, that how you can get the best of the serverless applications. Serverless themselves out of the box are very good, but how you can take the maximum benefits of using the serverless in terms of designing your ETL pipeline. Like the best thing could be, even though you put more jobs parallel and try to finish it, or have designed the pipeline in such a fashion where at much more lower cost, how we can process larger amount of data set. Now, the last topic is the observability, right? When in case of observability, how exactly you can get the visibility. So I think I've talked about, you can have the Spark UI, you can have Tage UI, those kinds of other things, what you can use for visibility based on the type of the applications, as well as AWS also pushed the laws into S3, and you can use the CloudWatch also. So not only the cloud native tools you can use, even if you're used to of using the traditional UI based tools for debugging or tracking your performance of the jobs, you can use the same. So that's about more of the theory aspect, I would say, about what exactly EMR serverless and those kinds of good stuff. And I think you guys would have understood a lot about it. Now I'll move towards the demo. And again, just to recap, there are 4 things what you have to worry about. What is application, job, worker, and pre-initialized worker, out of which 3 other things which will be common and which you will see in the demo itself. So first is you have to create an application in EMR. Second, we will submit an initial and maximum kind of an capacity. And third is around the entire submitter job. So these are the 3 things what we will be doing. I'll share this entire presentation and other stuff with the organizers. So you can have a look around the commands, as well as I'll give the GitHub repo. and the blocks which I've developed, where you can follow the same blocks and you can perform the same demo, which I will be showing now on the screen. So I'll switch to my other device. This is my AWS console, and this is my blog, which I was talking about. So I have developed an entire four series, four blogs here, where it start about how exactly you can work with Amazon EMR, starting from serverless, overview, glue, RDS, Metastore, as well as the entire orchestration of EMR. If you want to come with an airflow and other thing, you can do it. Please save this link. Here you will not only get all of my blogs which you have written, you can save this link and you can refer any of my blogs. Now moving back, I'll follow the blog which is Amazon EMR Serverless. So if you see whatever I've covered up as theory, I've just written as a kind of a blog itself. So if you want to go through it, more or less I've covered up everything in today's presentation, but still if you want to go through it, you can give a read. This is a demo what we will be doing. I've provided all the codes also here for the demo, like including the cloud formation URL, the screenshot at each stage. So this way, this will allow you to do the hands-on demo at your end. Now, first I've downloaded all of this artifacts, which is the cloud formation URL, the data set, as well as the script. Please ensure somewhere where I've already mentioned that, okay, you have to use a specific folder naming, like under the input folder, under the script folder. Please follow the steps properly to avoid any sorts of failures in the demo. So I'll move towards the AWS console. I'm doing my demo in North Virginia region. And first I'm going to the cloud formation console. In the cloud formation, for the folks who are for the first time on Amazon or have no idea about what is cloud formation is like an infrastructure as a code. So if you have any sorts of infrastructure, like infrastructure could be anything like launching a server, launching an IAM role, creating an Amazon S3 bucket, those all steps you can automate it with a simple JSON or YAML script. So you don't have to do again and again. It can be simplified. Okay, so this is the what stack name I'm giving. And you have to create next. No need to make any changes. The only thing what you have to do, you have to select all the three or checkbox. And this will take, I would say, a minute or two to get finished. If I take you towards template, what we are trying to do here is we are launching an Amazon EMR. We are launching an S3 bucket, an IAM role for our EMR, and other kinds of glue permissions and those kinds of stuff. So majorly, we are doing all sorts of prereq which is required for us to run this thing. Now, till the time this entire application is running, this will take like few minutes. It's already there. I will do is I'll open another tab and we'll bring up Amazon EMR console. Since I have visited Amazon EMR, so you can see at my home screen itself. But if you're very new, you can just search in the search bar Amazon EMR. Here you can search itself like what exactly is Amazon EMR. And just type Amazon EMR and it will take you to the service what you need. Not only for EMR, for any other services. Now here, don't go with this cluster, but you have to go with Amazon EMR Serverless on the left side. If you are using it for the very first time, this is how the entire landing page will look like if you don't have anything already in your account. This is how the pricing also looks like per vCPU, per GB storage cost. Again, don't worry about it. We are going to go ahead in detail, but that's the best part, that in this new console, you get the pricing, you get the cost calculator out of the box. So we'll go ahead and click on the manage application. Okay, so this is the entire thing has been stopped. Right, 1 second. Okay. So this is how the entire application will look like. What I will do is I will go ahead and create an application. So this is the way, as I said, right? First thing you all have to create the application. Now I will just say is serverless demo. From the option Hive and Spark, you can select one of them. I will select Spark. Here are the different versions of Spark. You can have 6.9, 6.8. I will use the latest one. You can also use the processor like for the Graviton, like Amazon EMR Serverless also provides Graviton, which is very optimized compute, I would say, for larger data processing and significant improvement in terms of the performance. But I'll use the first one since I have like very minimum amount of data set. You can provide your own pre-initialized capacity, right? Which we were talking about like from a worker standpoint. I will use the default setting because it's a very small and it's not production facing. So I'll use the default one. And create application. So now this application is created, but it's not started yet, right? So for that, I will click on this, which is an hyperlink. And we will start the application. This will take a couple of minutes to start application. Now start means this is where exactly my billing counter will start. But I don't have any worker nodes. If I would have any prerequisites, pre-initialized worker node, then from here my billing of the things would have started. But since I don't have it, it is going to be very minimum basic amount of the vCPUs. Now, till the time this entire application is starting, which should not take more than 2-3 minutes, we will go to the CloudFormation console and see where exactly the CloudFormation stands. So we can see the CloudFormation is ready and we can verify the output here. This is the job role ARN and this is the S3 bucket. This is exactly what we will use for our demo. So till the time the application is running around it, I'll go ahead and this time now I will move towards Amazon S3. So I've started my Amazon Serverless EMR application, which will take few minutes. Now I'll go to Amazon EMR Serverless, where I have to upload my script and data set for the demo, which I just mentioned that I've downloaded from the link given in my blog. So this is the bucket, which is what has been deployed from the CloudFormation. If you compare this with the output. So this is my bucket. The first thing what I have to do is create a folder as called as input. Here exactly I will store my data set. And second, I will create another folder for script to store my Spark script. Let me upload my data set. For that, I'll click on upload, add files. Here you can see this was a zip file, which I've unzipped it, and this are the data set, which includes 12 files. This is the word count exercise what I'm going to do with help of the Spark. Very simple application for the demo, but you can run the entire complex thing also. I've done the same thing in my blog. I've run the Spark as well as Hive, both kind of applications. But for the today's demo, I'll focus on the Spark one. It will take a few minutes to finish. In the meantime, if you have any questions, please put in the chat. I'll be happy to answer them. Now, next, I will upload my script. Yeah, I think there is a question about the blog link. Just give me a minute. Once I start the demo, I'll take the blog link and I'll put it in the chat. So here is exactly where I have uploaded my Spark code under script folder. Under input folder, I've uploaded my data set, and that's exactly what we have. Once we finish successfully running our entire Spark application via EMR serverless, you will see the third folder, which will be the output here. Now I'll go back to my serverless application and let me refresh. I hope by now the application would have started. Yes. So that means the application is good to go and I can submit a job. Job is nothing but, if you go back to our theory part of it, it is the request for the given application. So I've created a Spark application. So the request is going to be the same. This is exactly where I have to get my Spark code example, where exactly my Spark code has been saved. And here I'm going to give the location of my bucket. And same is what you can see here in this section also. If I go back quickly towards blog, you can see all sorts of screenshots, the demo, the script folder. You can see everything I've took a screenshot and have created a good comprehensive blog, which you can refer. Right? So here is what I'm giving the current parameter, the job name, the role, as well as the S3 script location and the entire output where I want to save, right? So I can just take this out. Right? Now, one thing which I've been just ensure when we define the entire S3 bucket, right? We have not given any sorts of folder in it. So please ensure when you're copy pasting the things from my blog also, just ensure what is your current setup. So if you go towards our S3 bucket, which I'm just using for the demo, there is nothing called as word count folder. Within the bucket directly you have input and the output script. So when you're running this application, please ensure that you give the right path. If you have the folder name, then give the folder name. If you don't, then you don't give it. Otherwise, it will fail with path not found error. So since I have not given, just remove the word count folder and we'll submit the job. This job here, you can see it will start running around it. It will start the job and you will see all those kinds of a life cycle, which is what job will generally go through it, right? You can see the Spark configuration, the entire Spark configuration, what we have given. Even you can see the entire UI part of it, right? What exactly the UI and all those things have been there. One second. Again, as I mentioned, the same thing, right? You have to be very careful when you're giving the path. I made the same mistake. I didn't give a right path, right? So now I will rerun this once to show you how exactly you can do it. So that's what exactly I want to show, right? Many people would say, oh, it failed. Now how I should troubleshoot it. So one is either you can go towards your entire UI application and look around, or you can see the status also, right? The status is very simple to debug. Exception, input part does not exist. And they have given the S3 also. So looking at the path, it is very simple to understand. Obviously, the servlet, the bucket name has directly the output folder. I mean, directly as the input. There is nothing called as output as a folder. So what I will do is I will again rerun this as a clone. And this time I will remove this output also, because there is nothing as an output as a parent folder within which you have this input and output. So I'll make that correction and rerun this. This I'm pretty sure it will go ahead. And in meantime, if you have any other questions, please put it in the chat. I'll be happy to answer them. I'm sharing all the links. I've shared all the social media as well as my blog link, which you can follow me. And DM me if you need any help. I'll be happy to help you out with that. So, yeah, as requested by one of the participants, I've shared all the links which I was talking about. You can follow me in all those kinds of platform. As well, I've shared my blog link. So as we can see, after we rectify our mistake, the entire application, the Spark application ran successfully. And I can verify the same from the entire S3 output. Previously, there were only two folders, input and script. Now we have an output folder also. And here is the output, which is written in a CSV format, which is nothing but the word count of it. So that's exactly what the entire application looked like. If you see the demo, if you just replay the demo, I've not done any kind of infrastructure, nor I've given any type of the servers like T2, T3, M5, C5. I've not given any kind of thing. I've just given a very simple Python Spark code, and I've start my application, define what kind of application it is, Spark, Hive, provide the IAM role, provide the data set, and it ran fine. So that's very easy. Like in few minutes, you can easily deploy EMR, configure, and play around with it. So that's exactly a very simple demo how you can play around with your entire EMR by creating an application, simply providing the capacity of it, and finally submitting a job. So if you're doing from a CLI or from some other command line, then this is how the command line commands are. What application, I mean, again, I've tried to cover up in my blogs all the different ways you can run via Airflow, CLI, CloudFormation. But if you are someone who has no idea about CloudFormation but are very good with shell and bash scripting, you can do with CLI also. If you're good with very Airflow kind of a guy, you can use that orchestration blog also. On that blog, I have a way how we can interact with Airflow. If you come with CloudFormation or DevOps guy, you can play around with DevOps. So that's exactly how you can play around with the demo and whatever we have covered up. Last few things on the pricing, which I mentioned. From a pricing standpoint, as I mentioned, it is already available on the console, which we saw a while back, right? It was very simple to understand it. This is the same logic what we saw in the entire previous slides also, that you're not paying for the cumulative, I mean the entire higher number of servers what you need for the total duration of pipeline. You're paying what exactly you're using at every instance of time, right? So it's not even, let's say it's a cumulative. Let's say if you're running a 10 worker for only 10 minutes, you're only paying the cost for 10 minutes. Even if for running 10 workers for 1 minute, you're only paying the cost for that 1 minute. It's not that there is a bare minimum time slice or time window what you have to pay the cost. No, it's not that the case. That's how it makes us more easy to use, cost effective to play around with it. Last, from a pricing standpoint, I don't think anyone is going to remember about this pricing standpoint, but just do remember it's serverless, pay per second billing, aggregated resources used for vCPUs, memory, and storage, and the vCPUs per GB. That is what the cost is. But if you can see the numbers, right, it's not even like 1 cent. It's close to like 1 cent or sort of a thing. So it's very, very cost effective to play around with it. And that's exactly here we come to our end of our session. Thank you so much for joining my session on Sunday morning, afternoon, or evening, wherever the part of the world you are. As I've mentioned, I've given all the blog links. I'll also package my presentation and share that in the same blog under the section, right? If you go through my blog, you'll see a talk. So whatever the talks I've done in the past, as I mentioned, I've done multiple of them in reInvent and all. So you can watch my other sessions, as well as I'll put my EMR also here along with my presentation. So you don't have to worry about moving different places. You will see one of more pages will be live by tomorrow, where you will have my entire GitHub repo for the code, as well as the entire presentation. Or you can reach out to the organizers of the sessions. I will share the presentation with them too. So that's exactly what I have today for you guys from my session. I'm open if you have any other questions, FAQs, anything which I can help you with it. I'm open to talk about that.
So participants, you can post your question in the chat. So participants, you can unmute yourself and you can have a session with, have a chat with.
Sanchit, it is EMR is primarily used only for machine learning this purpose like big data and these things, correct?
EMR, ideally, I would say, yes, many people also uses for machine learning data analysis, right? The EDA, exploratory data analysis, what has been used for prepping up the data set in the first life cycle. EMR serverless is primarily used for big data processing or for EDA. EMR on the other side, I mean, there are Spark ML and those kinds of libraries available, which you can run on Amazon EMR, which is on the cluster mode, not on the serverless.
Right. Compared to the on-prem, it is having more edge towards the big data thing, correct?
Exactly. I
Thank
mean,
you.
if you compare, so there are various different dimensions where you can think about it. If I take as a features, it's
Right.
neck to neck, I would just say. Again, the way people, I mean, the other industries are adapting to the cloud, obviously from a security or the accessibility standpoint, EMR has a slight upper head. If you talk about the cost, obviously cloud will have an upper head. Governance security, I would give on-premise a little bit more slight edge over EMR because you have a dedicated cluster, right? In case of EMR, there are certain tools like Atlas and all, which is provided in on-premise, are still yet not there. There is Ranger and all, and even Lake Formation. Those all things provided, but Atlas, which is a very good governance tool, I can see, which is there in on-premise. I think Data Zone, which is an AWS service, should cover up that. But again, as of now, there is nothing.
So you explained the job and workers, am I right? If you say that like a couple of nodes are not used, then we are not going to get the pricing for it, correct? Like when you distinguish this, like 10 nodes are there, out of 2 nodes are not used. So obviously pricing is not, that is a good advantage, am I right?
That is exactly depends on what kind of worker nodes are you using. Are you using pre-initialized or are you using the normal worker? But if I talk about the EMR EC2 or EMR cluster, right?
Right.
That is going to charge you, even though you are using it or not. You are paying
Oh,
the cost of EC2 in that.
okay.
Because
So
it's not
you,
serverless, right? I mean,
right,
in case of EMR, let's say I don't fire any kind of a job and the cluster is running for 24/7, you are paying the cost for it. That's exactly where the serverless in general comes into, right? That you're
right,
only paying the cost of what you're been using. So
right,
that's exactly the serverless comes into it. And even serverless also, there is something called as normal worker, the entire warm pool versus non-warm pool, right? The normal worker
right.
is a warm pull. When you start the application, you're paying the cost, but not for the other side of it.
Okay. So you mean to say that like whether the worker is active or not, still we have to pay for it, correct?
Depends on what kind of worker you're using
Okay.
and whether it's an EMR serverless or EMR on EC2.
All right, right. Got it. Thanks, thanks. Thank you.
So participants, you can unmute yourself and you can ask the question. So I think, so now we can move to the certification desk. We are going to share the secret key to you. So let me share the screen. So the participants, the secret key is secret code for downloading the certificate is VUDLGH. Let me post it in the chart. So participants, the secret code for downloading the certificate is VUDLGH. So the link is provided already. The link is provided to you in the chart. You can click that link and you can provide the secret code. Once after providing the credentials and or after login, you can provide this link and provide this code and you can get the certificate. So if you are facing any issues in downloading the certificate, you can communicate us in the given Telegram channel. So that's all from the certificate desk. I hope that you enjoyed the session. That's again a wonderful session and wonderful insight given by Sanjit Jain on Amazon EMR Serverless. Hope that you enjoyed the session. We'd like to thank Sanjit Jain on behalf of Multi-Cloud for you. Thank you.
Thank you, Gavaskar. As usual, thank you giving for this opportunity. And please, you can ping me if you have any other questions. I'll be available outside this session. So you can reach out to me on LinkedIn, Twitter, just DM me, and I'll be happy to help you out. Thank you.